Okay, so let's look at number 5. It says, write each of the following graphs in both standard rectangular form and parametric form. Okay, so let's look at the first shape. First of all, I do notice that from a -1 to a 6, I have a jump of 1, 2, 3, 4, 5, 6, 7. Okay, so it's a jump of 7 that is going straight up. Okay, so let's do this here. So basically you could say the radius is 7. And then if I look from -2 to 5, this xy is traveling also 7 units. So because those two are the same, we know that this is going to be, in fact, a circle. We're going to say the radius is 7. And we can say that the center of this circle, of course, is at -2, -1. Okay. So a circle, because of the fact that these were the same lengths, otherwise if they were different it would be an ellipse. The r is 7 and the center is -2, 1. And if we remember, the circle's standard form was x minus h squared plus y minus k squared equals r squared. Be careful that you remember that this is r squared. Okay, so we know that our x value is going to be plugged in here for h. And then we know that our y value is going to be plugged in here for k. So it's x minus a -2, which becomes x plus 2. And then it's y minus a -1, which becomes y plus 1. Again, a good way to remember that is these numbers, as far as my center is concerned, will be opposite over here of what's in parentheses, just like we've discussed from before. Okay, for parentheses, we're interpreting the opposite. The radius is in fact 7, so we're going to say 7 squared. Otherwise, let's put 49. So again, remember that this over here on the right side is not just r by itself. That's a common mistake for these tests. It's r squared, so we're going to put 49. So let's look at the parametric form. So parametric form, we have x and we have y. And remember, the very first numbers that we put are in fact the center of what this circle will be. So x is -2 and y is -1. We don't interpret the opposite here. It's exactly what it is because it's not in parentheses. So we're not going to interpret the opposite signs. And now we just have to make sure that we do times the radius cosine of t or cosine of the angle. So you could put theta or t there either way. And then because of the fact that the radius is the same, that will also be 7, but this is sine because it's y. So you have the following is the answer. So standard form for a circle is this one here, and parametric form for the circle is there. Again, just things to recap. Notice that the 7s are in fact showing the same kind of radii, both for the x and the y. Let's go to this ellipse. Okay, so let's this time start with the parametric form. Okay, and I'll say x equals y equals. I do notice that my center is -4 for x and +3 for y. Again, we're not interpreting the opposite. It's exactly how you see it. And now what I want to see is x-wise, it's going to be 1, 2, 3, 4, 5, 6 units. So we'll do a +6. And then y-wise, it's going to be 2 units. So we're going to do a +2. Okay, these will always be positive also, by the way, just so that you know. And when we come over here to the cosine of t, because cosine is x, and sine of t, because sine is y. Okay, that's going to be as far as the parametric is concerned. Again, if you wanted to, I'm not saying you have to, but if you wanted to make these values here thetas, I mean, it's still going to be the same thing because it's talking about the angles themselves. Okay, so now let's go to the standard form. An ellipse, we know the standard form will always add fractions with an ellipse that equal 1. Okay, so it will. That's also from the equation formula chart. So now I just have to interpret the x value came from a -4. So we're going to put x plus 4 in parentheses squared. And then the y value came from a 3. So it's going to be, y minus 3. Again, an opposite interpretation. Okay? And then underneath here is going to be a squared. And underneath the y is going to be b squared. Just to recap, x and y alphabetically, a and b alphabetically, and we know that a is always correlated with x and b is always correlated with y. Okay, so let's see x-wise. We know that there was a jump, okay, from what we showed before. There was an x jump of 6. That was from this -4 all the way to 2. That was a jump of 6. Okay, so 6 squared is going to be 36. And y-wise, we saw that there's a jump of 2. So b is 2, otherwise 2 squared is 4. So this right here would be your equation that would be standard form, okay? And this right here would be the form that would be parametric. Okay, so now, still with 5, what we're going to do is we're going to go on to the next slide, and we're going to show the relationships with the hyperbolas, okay? So both the standard and the parametric form. Let's do this time both standards at the same time, and then both parametrics at the same time. So you can compare, contrast, and see what are the similarities and differences. Okay, so let's begin on both. My center for this first one is 3, 1. Okay, the center over here is 0, 2. Okay, now we're going to come over here and we're going to try to identify what are our A values and what are our B values. Okay, so we do have to remember that A is affiliated with X. Okay, so we want to know what A equals, and Y is affiliated with B. So A, let me color coordinate this. A is going to be this jump to the left or right from that center point. Okay, so that looks like it's going to have a jump of 2 units. So A is 2. And then B-wise, it looks like we have a jump from 3, 1 all the way to 5, 5. So from 1 all the way to 5, that's a jump of 4. So it looks like B is going to be 4. Okay? All right. So again, if you wanted to see the jump of how A happened, you could look at this value of 3 and this value because they're associated with X, and you could see that it jumped up to the or over to the right by 2. Okay, so let's look over here. We know X is talking about A. We know Y is talking about B. And now we're going to do the same thing like we did over there. This A has a jump of 3. It's going from 0, 2, otherwise X is 0, all the way over here and have X is 3. So if you wanted just to look at the points, you didn't necessarily have to see the graph, but you could see that that jump is going to be all the way 3 over. Okay, so A is going to be 3. Let's go ahead and highlight that. And then B is going to in fact be the jump that's vertical. Okay, so B is with Y. Remember that. So up here, 1, 2, 3, 4, 5, it looks like B is going to be 5. All right, so 2, 4, and 3, 5. Now, because of the standard form of this equation is a fraction subtracting a fraction instead of adding like the ellipse was, this value here, whatever is positive, because that one's positive, this one over here is negative. So this first piece, the one that's positive, is going to tell us what direction is it looking. Is it looking up and down, or is it looking left and right? Okay, so because of the fact that this is looking up and down, this positive piece is going to be with the Y. So the Y is going to come first, or the Y is going to be positive. And I'll show you what that means here in just a bit. So we're going to have Y in parentheses, and the center is 1, so we're going to put minus 1. And it's going to be subtracting X in parentheses, where the center is 3, so we're going to put minus 3 because opposite interpretation. Now we just got to remember that B is 4, so it's going to be 4 squared. And then we remember that A, which is 2, it's going to be 2 squared. So it'll be 16 down here, and it'll be 4 down there. Okay. Now, you may see let's say possibly on a multiple choice or the way it's given, you may see something that looks like this. A negative x minus 3 squared over 4 plus a y minus 1 squared over 16 is equal to 1. Guys, these two are the same, okay? And just remember, whichever one has the positive sign, so positive y, that's why it's saying that it's going to be looking up and down, okay? Whatever one has the positive sign will tell you with hyperbolas what direction it's going to be looking. Okay, so let me go ahead and erase and make a little bit of space for my parametric form, but you could write any one of those forms that I just did as far as for your standard form. Okay, so the parametric, we have x, we have y. Oops, let me actually do the standard form over here like I was saying I was going to do them at the same time. Okay, so the center is 0, 2. This is looking left and right. So we know the x is going to come first, otherwise be the positive. Okay, so this is equal 1. And the y is going to come second. Okay, so x, okay, so let's, just like we did over here, as far as the center is concerned, let me highlight this in gray. This 3 was over here with x. This 1 was over here with y. This x is going to be here, so I really don't need to put anything there since it's just going to be 0. So let's go ahead and just take that off real quick and clean it up some. Because x plus 0 or x minus 0 is going to still be x. So we'll have x here squared. And then because it's going to be a positive 2 here, opposite interpretation says we're going to put minus 2 over there with the y. Now, a goes with x, so we will put 3 squared, otherwise 9 down here. And b goes with y, so we'll put 25 because it's 5 squared. So this is the standard form for this one. Now we're just going to finish it off with the parametric forms for both. X equals something, y equals something. And then over here we'll do the same. X equals something, y equals something for parametric. Now I'm being a little bit too fast here and I don't want you to do that on the test. Let's take a little bit of pride in that. And we'll clean it up with nice pretty braces. And we'll definitely clean up this one over here that's really sloppy with nice pretty braces. Okay. So the center over here was 3, 1. So we're going to have, just like we see it, no opposite interpretation because there's no parentheses. This is 0, 2. You can put that 0 if you want, or you can just leave it off. Either way, it's going to be okay. And the shortcut way to remember which one belongs with which is try to imagine these. This is how I show my students. Imagine these almost like eyeballs. Okay, so this eyeball is looking out this way, and this eyeball is looking out that way. Okay, so it's, or flashlights if you will. You're shining the light y-wise. So if the light is shining, otherwise it's facing, otherwise it's seeing y-wise, then that secant is going to go with the y. Okay? So that secant will be secant of theta or t, and the other one's going to be the tangent. Just like over here. This one was looking x-wise, so with x, that's where the secant is going to go. And when I say looking, I'm looking, where is it seeing? And I know that's kind of weird to say, but where is it looking? Where is it seeing? And again, this C almost looks like secant. That's just the way that I help my students as far as familiarize which one is which on a time crunch, short term basis. Okay. So now I just have to finish it off by seeing what are the A values. So A was 2 here, and we know that belongs with X. So that'll be positive 2. B was 4 here. We know that belongs with Y. It'll be a positive 4. Again, these will be positive nonetheless. A over here, which goes with X, is going to be 3, and Y is 5, so it's going to go here with the Y. So these are the parametrics. And yes, if you would like to take this 0 off and just keep it as X is equal to 3 times secant of t, you are more than welcome to. And this would be the answer for your parametric, and this would be the answer for your other parametric.